MS Ramaya University of Applied Sciences.
Hi students, let us have a discussion on synchronization of alternator with bus bar. The objectives of this laboratory experiment are to synchronize alternator with bus bar. Introduction. Alternators are connected in parallel to increase the output capacity of a system beyond that of a single unit. It serves as additional reserve power for expected demands or permit shutting down one machine and cutting in a standby machine without interrupting power distribution. The generators are synchronized when the following conditions are set. Equal terminal voltages. This is obtained by adjustment of the incoming generator's field strength. Equal frequency. This is obtained by adjustment of the incoming generator's prime mover speed. Phase voltages in proper phase relation. This is checked synchroscope or by using lamp method. To verify this experiment, we need circuit panel, 3-phase alternator coupled with DC shunt motor, single-phase auto transformer and connecting wires. Experimental procedure. This is an experimental setup of synchronization of alternator with bus bar. Connections are made as per the circuit diagram. Vary the DC drive to get the rotor at the rated speed. Switch on the field and bring the voltage of the alternator same as that of the bus bar. Fine adjustment of the speed can be done with the help of field rheostat of the motor. All the lamps will be dark when the conditions are satisfied. And close the switch to put the incoming alternator parallel to the infinite bus bars. While conducting this experiment, we should take some precautions. Loose connections should be avoided. Circuit connections should not be made while power is on. Readings of the meters must be taken without parallax error. Synchronizing switch must be closed when lamps are completely dark. Discussion. Alternator synchronized with infinite bus bar by dark lamp method is verified.
Hello students, today we are going to perform an experiment on 3-phase alternator. The aim of the experiment is to synchronize the alternator with the infinite bus. To perform this experiment, we require following apparatus. The apparatus required to perform this experiment are 3-phase alternator with synchronizing facility. This is our panel board. This panel board consists of 3 supply indicator switches R, Y, B and 32 ampere fuse, 1 TPST switch, on off push button, supply indicator lights for each phase R, Y, B and these are the connecting terminals. Apart from this, we are having a DC voltmeter of range 0 to 300 volts, DC ammeter of range 0 to 20 amperes, DC ammeter of range 0 to 2 amperes and again one tachometer. These are the terminals of the DC motor. This A is the terminal 1 of the armature of the DC motor. AA is the other terminal of the armature of the DC motor. Similarly, F and FF are the 2 terminals of the field winding of the DC motor. These are the terminals of the 3-phase alternator R, Y, B along with one neutral terminal. Along with this, we are having the field terminals also. F and FF are the field terminals of the alternator. Coming to here, this is the DC motor drive. This supplies the power to our DC motor. Here we are having one TPST switch, on off push button, speed control knob and the terminals to connect the motor field, terminals to connect the armature. Here we are having the alternator field rectifier. Alternator requires DC supply for its field, so that we are taking single phase AC supply as the input to the rectifier and rectifying that we are supplying from output of the rectifier to the alternator field. The part which is shown by me is the generalized meters and equipments what we have observed in all our previous experiments. Apart from this, to synchronize our alternator with the infinite bus, we are having the following meter. This is called synchroscope. It will indicate whether the incoming alternator is slow or fast when compared to the infinite bus. This is the voltmeter. It will show two voltages. One is system voltage, another one is incoming alternator voltage. This is the very important equipment. This is called reed type frequency meter. If you observe, we are having two frequency scales here. One frequency scale is for the system frequency, the another scale is for our incoming alternator frequency. If both are matched at 50 Hz, we will synchronize our alternator. Along with this, we are having two AC wattmeters of the range 15 amperes by 600 volts, AC voltmeter 0 to 600 volts, AC ammeter 0 to 20 amperes. Here, in order to observe the synchronization very clearly, we are having lamp setup. 6 lamps are arranged, 2 for each phase. You can observe 6 lamps, 1, 2, 3, 4, 5, 6. The incoming alternator terminals brought here and the existing system terminals are brought here. When all the parameters are in agreement, we will close the switch and we will synchronize our alternator with the infinite bus. These are the two on-off switches provided for source metering. Here these are the output terminals. From this we can load our alternator. Single phase auto transformer ranges from 0 to 270 volt. These are the connecting terminals. One is phase terminal, another one is neutral terminal. This is the indicator bulb. 300 ohm by 2 amperes rheostat. For this rheostat, the connecting terminals are shown here. This is connecting terminal and this is also a connecting terminal. Along with these two terminals, we are having one more terminal here. Connecting wires. These are the connecting wires. Based on the circuit diagram, we will connect the circuit. Along with this, we will have a 3-phase alternator coupled with DC shunt motor. This is a 3 kVA 415 volts 3.8 ampere alternator and it is coupled to DC shunt motor. DC shunt motor acts as a prime mover for this alternator. Now let us start the experiment based on the circuit diagram. Take the connecting wire and start connecting from motor field. From motor field to connect to rheostat variable input point. Now connect from the output terminal of the rheostat to the 0 to 2 amperes positive terminal. 0 to 2 amperes ammeter positive terminal. 0 to 2 amperes ammeter positive terminal. From the negative terminal of the 0 to 2 amperes DC ammeter, connect to F terminal of the DC shunt motor field winding. F terminal of the DC shunt motor field winding. From FF terminal to connect to the motor field negative terminal. This completes the field connections of our DC shunt motor. Now we will connect the armature circuit. Take one more connecting wire and start connecting from to motor armature that red terminal. From this red terminal to 0 to 20 amperes ammeter positive. From 0 to 20 amperes ammeter negative terminal to A, the first terminal of the armature winding of DC shunt motor. From AA terminal, that means second terminal of the DC shunt motor armature to armature negative terminal. Now connect a voltmeter across the armature terminal. Take two connecting wires and connect the DC voltmeter of the range 0 to 300 volts across the armature from positive terminal to A, and from negative terminal of the DC voltmeter to AA terminal of the DC shunt motor. This completes our DC connections. Now we will connect the alternator connections. Take one wire and connect from R terminal to R terminal on the synchronizing panel. Take one more wire and start connecting from Y terminal to the Y terminal of the panel board. Take one more wire and connect from B terminal to the B terminal of the panel board. Connect the voltmeter across the any two terminals of the alternator. Now we are connecting 0 to 600 volt range AC voltmeter across R and Y terminals. This is connected between R and AC voltmeter. Take another wire and connect from Y terminal to the another terminal of the voltmeter. Now take three long wires and connect the system voltage. That means power system terminals we are bringing to our synchronization panel. R terminal of the input is given to the R terminal of the synchronizing panel. Similarly, Y terminal of the input supply is given to the Y terminal here. Take one more wire and connect from B terminal to the B terminal of the synchronizing panel. Clear. Now we will connect alternator field circuit. For that we require a single phase auto transformer. Take one wire and start connecting from the phase terminal of the single phase auto transformer to phase terminal of the alternator field rectifier. Phase terminal of the alternator field rectifier. From the negative terminal, connect to N terminal of the alternator field rectifier. N terminal of the alternator field rectifier. Now take one more wire. The output of the rectifier, the red terminal of the output of the rectifier is connected to the F terminal of the alternator field. From FF terminal connected to the negative terminal of the alternator field rectifier output. This completes our circuit connections. Now switch on the power supply. Before turning on the power supply, the source metering switches must be in their on position, and in the two TPST switches, turn on one TPST switch. On. Field rheostat must be at its minimum position, and the single phase auto transformer must be at its minimum position. By ensuring these conditions, we will turn on the power supply. Switch on the power supply. Now turn on the TPST switch, turn on the on push button. In the DC motor drive, turn on the supply and push the green button. Now by varying this control knob, you have to set 220 volts voltage in the DC voltmeter. Now I am varying the voltage. Slowly vary the voltage and bring up to 220 volts. is the 220 volts voltage. Now vary the rheostat till the tachometer reads 1500 rpm. Now I am varying the rheostat. Now the alternator is running at 1500 rpm. After setting the speed to 1500 rpm, we have to give the field excitation. Before giving the field excitation, for the more accurate observation of the system voltage, we will take one multimeter and we will connect multimeter across the supply terminals. That means bus bar terminals. Now observe the voltage of the bus bar, that is 394, 396 varying. Now we will develop the voltage in our alternator, the same value which we are observing in the multimeter. Now slowly vary the excitation for the alternator. While varying that one, the speed must be constant at 1500 rpm. Make the speed near about 1500 rpm. Bring the same voltage as in the case of multimeter. Observe the turn off and turn on of the lights. When the lights go completely dark, turn on this switch. Then your alternator is perfectly synchronized with your infinite bus. Now completely dark. Now I turned on the switch. Our alternator is synchronized with the infinite bus. Now you can observe the system voltage and the alternator voltage varying together, and you can observe the system frequency and the alternator frequency same. This completes the experiment. To turn off the system, first break the synchronism with the infinite bus. To break the synchronism, first close the synchronizing switch. After closing the synchronizing switch, bring back the alternator voltage to 0 by reducing the field rheostat of the alternator. Then bring back the rheostat to minimum position. Reduce the armature voltage to 0. Turn off the power supply. Push button. This completes our experiment.
At MSR UAS, we spark your imagination unlike any other.